happen in this world is science and technology will continue to develop, will continue to bring in newer and newer capabilities. And with these capabilities, we will have ability to look beyond our immediate surroundings. For example, you are all familiar, man started looking at celestial objects and whether it is the stars or formation of these eclipses and how these eclipses impacted human life. Just on the 26th of this month, you will have an opportunity to see near total solar eclipse. In the earlier days, when man was just getting into farming, and he was looking for celestial objects to tell him at what interval the things repeat, when does rain occur, and is there any correlation between presence of a particular group of stars and rainfall occurring. And that's how he started building empirical relationship, and astronomy and astrophysics started developing. And in our own country, if you look at when the first object was put into space by Russians way back in 1957, when Americans and Russians were really trying to compete with each other and find out who has the better capability, who is militarily more powerful. Actually, we had a great visionary scientist in our country. Probably you all are aware of his name. Can anybody tell? Vikram Sarabhai. In fact, we are actually celebrating his birth centenary year this year, and it was his vision that the technology of space, a technology where you can put objects around Earth in different orbits, low Earth orbit, equatorial orbit, or geostationary orbit. And by making use of these satellites, look at Earth and then look at what is happening on the Earth's surface, Earth's atmosphere, and also by bringing in a capability of equivalent of a tower. Because you are all familiar, if you want to see a vast region surrounding you, what you do is you try to climb to the highest point accessible to you, and from there you look around. Then you get an observation capability of a large area. In the same manner, if you look at a geostationary satellite, which is in the equatorial plane at a distance of 36,000 kilometers from Earth, because of the relative speed between the Earth rotation and the period such a satellite takes, exactly 24 hours, the satellite appears like a tower at a height of 36,000 kilometers. As a result of this, 1/3 of the globe is continuously visible to that satellite, and anybody from ground can communicate via this satellite to a region within 1/3 of the globe. And what Dr. Sarabhai conceived of was making use of the technology of space, how we can bring in rapid development in our country, how this process of scientific investigations done by people like Arthur Clarke, who had actually foresaw that one day a satellite operating in geostationary platform can be used for line of sight communication. What Dr. Sarabhai did was, he convinced Americans that you allow us to use a satellite which they were building at that time in their late 60s, an advanced technology satellite called ATSF. He asked them to provide that for 1 year, because you can imagine if a satellite were to look stationary from a point on India, obviously a satellite which is covering America cannot see this. So you have to relocate it from American longitude to Indian longitude. But he could convince them, and between 1975 and 1976, India conducted the world's largest socio-technological experiment of demonstrating how this satellite can be used for bringing information to about 2,400 remote villages in our country. By using a technology very similar to what you see today, using a set-top box and a small antenna, you can receive directly from the satellite a television signal, and you are seeing at home. You can imagine in 1975, almost 44 years back, India conducted the world's largest socio-technological experiment of doing for 1 year such an experiment using black and white television sets from our Electronics Corporation of India Limited, and in these villages setting up the direct-to-community sets and showcase to the farmers and the villagers the benefits of providing information, telling them about the welfare practices, telling them about the farming practices, telling the farmers and the villagers specific information. See, this particular example proved to the people in power that if India were to take advantage of the technology of space, then we can rapidly bring in both communication and transport, the broadcasting services to the country. Because at that time, if you were to go by terrestrial towers for transmission, you would require, we have almost 3.25 million square kilometers of surface area. And every 1 kilometer you require a microwave tower if you were to do the technology of that day. Then you can imagine how many towers would have been required and how much time it would have required for completing this activity. In a similar manner, if you are aware today, any super cyclone which comes, actually we are able to save the lives of people in our 7,500 long coastline by providing observation from satellites, looking at the cloud patterns, how the clouds move, and based on that determine the formation of the cyclone and also predict exactly when the cyclone hits the coastline. In the earlier decades, super cyclones used to cause deaths in the range of 15 to 20,000. But in the recent past, you would have seen that because of this specific information being available through the satellite observation, the numerical weather models have improved and you are able to tell with an error of less than 20 kilometers in position and half an hour in time. You can tell the disaster relief agency days in advance and they are able to evacuate the people in the coastline and save the lives. Today, in the presence of super cyclones, the loss of life has reduced to single-digit numbers less than 10. And all this is possible because satellites are put into different orbits. Today we have a capability of looking from space on India and surrounding India in different wavelengths. See, as you are familiar, we can see, our eyes can see between 400 to 700 nanometers. But you also know electromagnetic radiation occupies much larger wavelength region. Below the infrared, you have got the thermal, microwave and radio waves. And beyond the violet, you have ultraviolet, X-rays. So by what man has done with the development of science and scientific knowledge, he has built tools which help him look beyond what he himself can see. Today, if you look at, we have built sensors which can operate in microwave region. What is the advantage of the microwave region? See, as we can see through the glass is transparent to us, but we cannot see through the clouds. India has during the monsoon period, between June to September, if you try to look from space towards Earth, you will see a lot of clouds. So you cannot see through the clouds. But like we can see through the glass, microwave wavelengths can see through the clouds. And then by putting sensors operating in these wavelength regions, you can pick up what is happening on Earth. And then as a result of that, today we are also able to provide a center in Delhi called Mahantesh Crop Forecasting Center, where ahead of harvesting, what is the yield of crops? 11 different types of crops: rice, wheat, sugarcane, groundnut, sorghum, cotton, many such many such outputs of these products. We are able to tell to the government ahead of harvesting, 1 month, 2 months ahead of harvesting. In a similar manner, by looking at the entire ocean, you are able to generate ocean wind vectors. You can imagine if you were to build any model, a model which can predict the behavior of weather, then you need lot of inputs. Inputs like what is the temperature, what is the humidity, what is the wind speed, wind direction. Earth is covered almost 3/4 by the ocean, and you cannot put in the ocean lot of observation posts like we can do on land. Even on land it is limited, but still on land you can put many more observation systems. But over ocean it is difficult. That is where today satellites are able to make observation of ocean winds, ocean heights, ocean temperature, and using all this it's possible to provide inputs to the numerical weather model, and weather forecasting has become better, and that's how super cyclones and cyclone predictions are becoming better. One more thing that to provide to the fishermen specific knowledge about where they should go for fishing. In fact, how this is done is very interesting. From the satellites, you look at the color of the ocean. Look at the color of the ocean in 8 different wavelengths. And by looking at the signals coming from these 8 different wavelengths, you can actually determine what is the chlorophyll content in that area of the ocean. And through the chlorophyll, you can work on the food chain of the fish, and through this process determine in which region of the ocean, if you try to catch fish, you will get great success. In fact, this experiment that was done using the satellite data of ocean color instrument and also thermal front using thermal sensors was being provided to the fishermen from 1999 onwards through a center in Hyderabad called Indian National Center for Ocean Information Systems. And this alone saves to the country, because the fishermen now need not spend time and fuel searching where they have to get the fish, and saves between 15 to 20,000 crores a year. And to this we added a new capability recently. You are all familiar, in your mobile there is a tool which helps you locate yourself. It can tell you what latitude, what longitude you are based on the GPS system. We have come up with a system called Navik. While GPS requires between 24 to 32 satellite constellation for doing the job, we came up with only a 7 satellite constellation covering India and beyond India up to 1,400 kilometers beyond our borders. Over this entire region, today with a small handheld device, you can get to know latitude, longitude. So there is a small gadget which is battery operated, which can be fitted in the boat of the fisherman, and this gadget receives signal from the Navik and determines its current position. Not only that, in Navik we have a unique messaging capability. Through this messaging capability, we are able to transmit to that gadget what is the location where the fisherman can go. And this gadget, which is battery operated and is not connected to any terrestrial tower, because you can imagine when the fisherman gets into the ocean few kilometers away, no terrestrial tower can be in communication with the mobile. But then this mobile in the hands of the fisherman communicates with the gadget through Bluetooth or Wi-Fi, and an app in the mobile helps the fisherman like a video compass. It points to him where he has to go for fishing. Not only that, in his mother tongue, it can give alerts if the sea state roughness is going to become unbearable in the coming few days, and he is alerted to return, or if there is going to be heavy winds or heavy rain, occurrence of cyclone, or even if he is approaching an international boundary, it alerts him telling you are approaching international boundary, be careful. So now you can see a person who does not know reading or writing is able to take advantage of the most advanced technology of satellites operating in space in communication, remote sensing and navigation, and through that he is able to perform his daily course and living. So what the space science and technology has done today is enabling individuals who may not know reading or writing to take advantage of such a capability. So in this and many other similar things, today for example, you can easily visualize what is happening on Earth, any part of the globe. If you want to see, if you want to make use of it by a network of observation, it is very difficult. But if you go beyond the Earth's atmosphere into space, then you can look at any part of the globe. So you can see what is happening. And not only that, you can look at the atmosphere, and then by looking at the atmosphere, you can do climate change studies, or even many times, for example, if you want to know what is happening beyond the Himalayas or in other parts of the world, which will affect you, because some of you would have seen that if some place in the Himalayan region, if somebody tries to create artificial lakes and then release that water suddenly, there can be flooding, or many such things which can happen beyond the boundaries. Today, space technology enables you to make observation. While we started our work using sounding rockets in the form of kits, today you will be happy to know India is among the few countries in the world which has an end-to-end capability of launching satellites, building instruments, and not only that, use this satellite information in the areas of communication, remote sensing, navigation, and bring tremendous service to the society in various aspects, in various day-to-day living. Today we have more than 50 plus satellites providing us capability to look at India and surrounding India in a large number of wavelengths and also in microwave wavelength, and we have a capability to look at any part of the globe in resolutions better than a meter, and today we have a capability of a video being taken of any part of the globe for 1 minute with sub-meter resolution. And similarly from geostationary platform, we can look at India almost continuously during the daytime in 6 different wavelengths, and you can get a huge amount of knowledge base on this. And all this data, whatever is generated, is used for many applications where both the state and central governments are taking advantage of this capability. What is being done is, you would have heard of Manrega program, where in the earlier years, what was being done was not known. But the current central government is very effectively using this information, and for the last 2.5 years, using the geospatial technology and crowdsourcing methodology, more than 4.5 crore assets created using Manrega program is available in the database for both the central and state governments to not only monitor but also find out what things are happening and how the work is progressing. In fact, any citizen can see through our Bhuvan portal what is the progress that is happening in this platform, in these locations. So, and also in the earlier decades, where if you were to find out where to drill a borewell for getting water, that also was being done using the space technology. So you can see here that the vision of a scientist who had just returned from his studies abroad and who foresaw how development of science and technology can help the country make rapid progress in communication, and today the entire country is connected. We are building satellites which can give, you can say, very high bandwidth to Gram Panchayats. One of the satellites which is going to have 100 plus gigabits capacity, which will be launched in a couple of months from now. And using such a capability, providing the villagers not only broadband connectivity, but also all the activities which they need to do in terms of planning, etc. can be done. So the idea is here, science develops newer and newer knowledge base, and using this knowledge base, technology creates tools, and using these tools, we are able to provide an improved standard of living to the society. And so if we have to make an impact, you would have seen in India we had great scientists, great visionary scientists. If you look at Sir C.V. Raman, for example, he was able to do work using simple things, what was accessible to him. And it was at a time when the technology had not brought in so many new tools. At that time, by conducting experiments, very simple, innovative experiments, he showcased how Raman effect he discovered, and then based on that, a huge amount of applications came, and he was among the Nobel laureates from our country. In the same way, earlier J.C. Bose, also and Meghnad Saha, many of them did pioneering experiments. But at that time when they were doing the experiments, because we were not an independent country, we were under the ruling rule of the Britishers, many of the progress what they